Hello students, I'm back with the C++ function name overloading part 2. I'm Dr. Singhal. If you have not watched part 1, you should watch that before watching this one. So in part 1, I had set up an Xcode program, which I'm going to show you now. We had basically these 4 swap functions, which are taking, each one is taking int, double, character, and string respectively by reference, 2 values. And by the way, this is not to say that when you do function name overloading, parameters have to be passed by reference. There's no correlation between function name overloading and the way parameters are passed. Okay, so this is our program. First we make a call to swap1, and I want to show you that although the program has 4 functions named the swap, when I'm passing it to integer argument, it's only going to call this one. It's going to make exact determination based on the signature, and signatures include number of arguments, data type of the arguments, name of the function, and number of arguments in the parameter list. Okay, so we are in the debug mode here in Xcode, and in between I'm gonna turn on a magnifier to show you what the current value of val1 and val2 are. Well, I mean, it's obvious that as soon as I go past this line, val1 should become 5, and I do this something called step over. So is val right now 5? It is 5, and I can show that to you using a magnifier that, excuse me, that here in the expressions, the val1 did become 5. I'm able to print the value of the different variables here, and of course if I hold my mouse on val1, that will also show, although that's not showing up right now. It actually does, but it's kind of pretty faint, but it's there actually. Alright, so then I continue on, and by the same token, val2 will be set to 10, and again, if I had the magnifier, you can see it very clearly, but it's there actually. Okay. Now we are going to make the function call now. That requires stepping into, and that's this code. So as soon as I click on a button here, which you may or may not see, the control of function should really be transferring to this function here. And if that happens, that means function name overloading is working. And this is exactly what I'm going to show you. So I click here, and notice that C++ chose this function to execute, because although there were 3 other functions with the same name, the parameters passed were int type, and that's why there's a match here, there's no match here, there's no match here, and there's no match with the string either actually. Okay. And then of course it does its own thing. It does the swap mechanism. Temp is set to 5, and x is set to y value, and y is set to temp, which was 5, and we don't need to worry about seeing the expression values here. When we go back to main, we will see an output here which will show us the correct swap did take place. So we go back to the main now. Okay, and now these 3 couts should be done actually. So, and you'll see that. So after swapping integers, val1 is 10, which was actually 5 earlier, and val2 is 5, which was 10 earlier. Okay, so swap worked correctly, because even though there are 4 functions with the name swap, C++ was able to determine that since val1 and val2 are both integers, it should call only this one and ignore the other 3. Okay, we do the same thing with the double type. So this time, once again, I'm just going to do the step over, and double 1 is set to 5.1, double 2 is set to 10.2, and in expression value is going to show almost same value, but not quite, because floating point numbers are never representable exactly. So it's going to show that. Here we are calling the swap function again, and this time if function name overloading works, then C++ should really call this function and not any other, because two values passed to it are double type. Okay, so let's do this step into the function, and notice it correctly goes to that version of the swap that takes two double values, and then again it does the swap and all those things. That's actually almost automatic now. So I'm just gonna continue on, and the swap has been done now, and then I come back to main, and then here in the output window you will see what is printed. So it says after swapping doubles, DBL1 is 10.2, DBL1 earlier was 5.1, and then DBL2 was is now 5.1, which was earlier 10.2. So the swap works correctly here as well. So it looks like in these two cases function name overloading is working. Let's show it for the character and strings, and then we would have proven that it works in all cases. So in this piece of code, I'm setting character 1 ch1 to A and ch2 to Z. So those two values will be set. Now I want to call the swap function that takes two characters as an argument, and if function name overloading works, you should really call this one, ignore the other three. So I'm going to get into the function and see which function is being called, and notice the control is transferred to this swap, not to this one, not to this one, but to this one. That means since two characters were passed, C++ chose this to execute, not the other two. And once again the swap will occur, of course, because we passed by reference. And we'll go back to the main and print the values. And after swapping characters, ch1 is Z. Remember, ch1 earlier was A over here, and continue on, and ch2 is A, but earlier ch2 was Z, so the swap works correctly here also. Actually, we just need to demo the last one, which is the swapping of strings, and we just go here for that. So now we set male to John, female to Lisa, and this will be fine. Then we call the swap for the strings, which takes male and female strings. We jump into that, and notice that this time again control is transferred here because two strings were passed. Okay, and once again the swap will occur, and we'll print the values in the main function. So after swapping male and female names, male actually, which was earlier John, became Lisa, and female name earlier that was Lisa got swapped with the John. So basically what we have proven here is that even though there are four functions with the same name, when we pass integer to the swap function, two int values, then only this version will be called. When we pass two double values, only this version will be called. When we pass two character values, variables, then this will be passed. And when we pass two string variables, only this will be passed. So the function name overloading does work. Okay, I want to show you, a few minutes I have left, few other things about the function name overloading. You have seen them in use the power function, and in our ebook we have a whole bunch of stuff on that. So for example, POW function, which I'm pretty sure I have it somewhere. Let's see. Okay, so where did it go? All right, so I'm pretty sure it was somewhere. All right, I'll come back to that in a minute. Oh, here it is. So when you use the POW function in math library, it had two versions. One is this here. One is this, oh, I'm sorry. In one version, I can pass two double values where base and exponent both are double type. So for when both values are double type, C++ calls one version of POW. Remember there was 4 versions of swap, so it has one version of POW that is called. But when exponent is made integer, although base is left double type, then it calls another version actually, okay? So one version is POW double double, which is called here. Another version is POW double int, that is called here, okay? So you've already seen that in POW, use of POW function, the function name overloading was used. I only want to show you one more time. I want to emphasize that if return type is not part of function signature, so difference in return type cannot be used in order to do the function name overloading. So for example, okay, over here I have two functions where notice the name of the function same, my function. Argument types, number, order is exactly same. Int, string, double, int, string, double. Only difference is one has a float return type, other has int return type. This will be a compile error because you cannot just alter the return type and hope that functional name overloading will work. That's not going to work actually. Okay. But here I have 4 functions here, my function. These 4 will be allowed because this has 3 argument, int, string, and double, but this has 3 argument also, but the order is changed. Order is not the same as this one or that one, okay? So that means that if I take combination of, if I exclude the return type and take the combination of name, number of parameters, types of parameters, and data type of parameters, signature of actually all 4, not just 3. Signature all 4 is different or different. So all 4 of these will be allowed, okay? Other thing, you cannot do overloading by, if you pass in one function parameter by value and another parameter by reference. That's not part of the signatures, okay? So changing the mechanism of parameter passing is not going to allow you overload, because really in these 2 cases signatures are identical. And same thing here, between these 2 the signature is identical also, because really only thing that has changed is the const reference here. So this will not be allowed as an overload mechanism either, okay? So signature of these 2 are same also. All right, so this is the story about function name overloading. Hopefully you've understood it, and hopefully you can apply them in the software solutions that you'll be seeking in the future. Thank you so much. Bye.